Hello everyone. Today is Tuesday, May 26th, 2026, and I am super excited to welcome you back to the channel. I'm your host Mayo, and today I am introducing a trending article from the archives, which is something I've been meaning to talk about for a while. I was just thinking about how much time I spent reading Limelight, and I realized that if I were an encyclopedia, I would probably be a very confused one because I have too many tabs open in my brain. Get it? Encyclopedia. Oh, moving on. So today we are looking at a fascinating piece of research that digs into how artificial intelligence actually learns from the internet. The title is to document educational or just Wikipedia style pitfalls of Wikipedia-based quality filtering. The call is You receive Owens Buddy 605.23,721. It is long, but please bear with me because this is going to blow my mind. Let us get right into the thick of it, because the problem that this paper is trying to solve is actually a huge deal for the future of artificial intelligence. You see, when companies build massive language models, they have to feed them a ton of text from the internet. But not all text is good text. To make sure the AI learns from high-quality stuff, they use something called Classifier-Based Quality Filtering, which is basically a gatekeeper model that scores text based on how educational it looks. The assumption is that educational data makes the final artificial intelligence much smarter and more reliable. But the researchers in this paper found a critical vulnerability in this system, and it is honestly kind of hilarious but also terrifying. They discovered that you can trick this highly advanced gatekeeper just by taking a really low-quality piece of text and reformatting it to look like a Wikipedia article. They used a simple filtering tool to change the style without changing the actual facts, and suddenly, the filter model thought this garbage text was highly educational. The paper notes that about 7% of the evaluated documents that should have been thrown in the trash were actually let through the filter just because they were dressed up nicely in a Wikipedia-style format. When we compare this technology with other older methods, it becomes really clear why this is a problem. In the past, which looked at basic things like language identification or the ratio of letters to special characters, these older methods were pretty straightforward and hard to trick with just a style change. But they were also kind of dumb and missed out on nuanced content. So the industry moved to these smart, plus facial models, which use neural networks to judge the educational value of a text. But because these smart models were trained on data generated by other language models, they ended up learning the wrong lessons. They learned that lines organized with clear headings and bullet points are automatically good, even if the actual content is just someone rambling about their cup of tea, which is a real example from the paper, by the way. The researchers actually had human imitators look at the same texts, and the humans gave much lower scores than the artificial intelligence did, proving that the machine gatekeeper is overly optimistic and easily fooled by superficial appearances. Now let us talk about the application to everyday life, because you might be wondering why you should care about how artificial intelligence filter works. This impacts almost every piece of technology you interact with that uses a language model, which nowadays is basically everything. If the AI is trained on junk data that snuck past the filter just because it looked pretty, the answers it gives you when you ask it a question will be low quality and potentially full of subtle biases or just plain incorrect information. This brings me to the 3 specific application examples based on the content of this paper, and how this technology and its pitfalls could be applied or impact the real world. Let us look at the world of EdTech, their educational technology. Companies are constantly building personalized AI tutors for students, and they need to curate massive libraries of study materials. If they use these flawed classifier models to automatically sort through the internet for good study guides, they might end up feeding kids information that is totally useless, just because it was formatted like a textbook. By understanding the vulnerabilities pointed out in this paper, EdTech developers can build secondary verification systems, maybe combining the old heuristic filters with the new classifier models, to ensure that the content is actually factually accurate and pedagogically sound, rather than just looking smart. Second, this research has massive implications for verifying and defending against data poisoning. The paper explicitly mentions the malicious actors could leverage these limitations to bypass filtering and promote their own dangerous agendas. Imagine someone create a network of websites filled with subtle propaganda or hidden backdoors, and then formatting all of that text to mimic the structure of a high-quality Wikipedia page. AI companies would scrape the web. Their classifiers would give this malicious text a 5 out of 5 for being educational. And suddenly the base model is permanently poisoned by exposing this Wikipedia-style loophole. E-burst and Tree teams at major tech companies can now create adversarial training programs where they intentionally try to trick their own filters with beautifully formatted junk, forcing the gatekeeper models to actually look at the meaning of the words instead of just the layout. We have the application of ensuring fair representation across different domains of knowledge. The researchers found that these educational filters have a massive bias towards certain subjects, like science and technology, while completely ignoring or downranking other topics, unless they are forcefully referenced into a Wikipedia style. In the real world, this means that an AI trained strictly on this filtered data might become incredibly bad at understanding conversational text, creative writing, or cultural nuances from domains like books and literature. If you are a company trying to build a creative writing assistant or a conversational chatbot, relying on standard educational filtering will ruin your product. Developers can use the insight in this paper to adjust their filtering thresholds based on the specific domain, ensuring what it with it pierce it, and creating language models that are much more well-rounded and human-like. What we are seeing is that as our artificial intelligence systems get more complex, the ways they can fail get a lot weirder. We tried to make a filter that understands what education looks like, and instead we made a filter that just really loves Wikipedia for name. It is a huge wake-up call for the machine learning community, and it shows that we cannot just blindly trust a model to curate our data without checking its homework. Thank you so much for hanging out with me today and listening to this deep dive, and I hope you found it as interesting as I did.